Adding a little bit more information to the projections here, we will look at the regional. So every region faces more severe and or frequent compound and cascading climate risks. Compound events are couple of multiple events that occur together, and cascading climate risks are something that starts with one kind of a climate risk and then cascades into others, floods and droughts cascading into food risks and bioenergy, for example. Increase in the population exposed to sea level rise from 2020 to 2040. I don't know why I keep fumbling these. Exposure to a coastal flooding event that currently occurs on average once every 100 years. Already in 2020 in North America, 0.34 million people are exposed, and absolute increase in percentage increase for 2040 will be plus 0.24 million, so that's 71% jump from today's numbers. Central and South America, the increase will be 35%, but the absolute number is already much higher at 0.69 million. Small islands, it goes from 0.18 million to jumps by 0.1 million, so 57%. Europe has 0.67 million exposed already, and it will jump further by another 0.38 million, so 57%. Africa 2.4 million, another 95% jump will occur on top of that. So the 2040 numbers here are related to a scenario chosen as shared socioeconomic pathway 2-4.5. So 4.5 is the middle of the road emission scenario with the 4.5 watts per meter squared increase by 2100 in additional forcing at the top of the atmosphere, and SSP2 is in terms of the mitigation and adaptation and regional conflicts and choices, etc. So the increase due to sea level rise only and increase due to sea level rise and population change is shown with the orange color and the lighter orange color. So there are all kinds of details added, but obviously one has to realize that population projections are quite uncertain, and sea level rise themselves can be quite uncertain as well. So one has, especially because many of these calculations do not include melting of land glaciers or land movements and so on. Africa has a massive number, 2.4 million exposed already, and will further go up by another 2.29 million, so that's a 95% increase. A lot of it will come from increase in population as well as the increase due to sea level rise itself. And Asia, the biggest number here, already exposed 63.81 million in 2020. It's going to jump up by another 16.36 million, so 26% jump. Quite a bit of it is coming from population increase and some coming from the sea level rise itself. Australia is relatively safe with small numbers, but still it'll also see an increase. Increased frequency of extreme sea level events by 2040. You can see the hot spots all over the world, especially in the global south. So frequency of events that currently occur on average once every 100 years. The absence of a circle indicates an inability to perform an assessment due to a lack of data, and not that everybody is safe over there. These circles read as annual events in the dark magenta color, decadal events, twice a century event, and if there is a small white circle, then there is no change. There are very few of those here. Projected change to 1 in 100 year events under the intermediate SSP 2-4.5 scenario. So that's what we are looking at. So you can see that large parts of Japan, China, North Central America, large parts of Europe and Africa here in southeastern and southwestern edges, as well as Central African countries here on the east, are all at great risk. Of course, island states always are sitting ducks in many ways when it comes to sea level rise and extreme events. Example of complex risk where impacts from climate extreme events have cascading effects on food, nutrition, livelihoods, and well-being of smallholder farmers. So you are looking here at the feedbacks between various events that can cascade. More frequent and more intense extreme heat and drought will lead to reduced soil moisture and health and food yield and quality losses, as well as direct impact from extreme heat and drought to food yield and quality losses, and that will feed onto food prices and then lead to reduced food security, increased malnutrition, decreased quality of life, which will also get hammered from the other side in terms of food yield and quality losses, leading to reduced household income, reduced labor capacity, and decreased quality of life. So you can see that there are arrows going in every direction. So this is typically going to be very bad for poor people, whether they are in the global north or global south, but global south on average is going to get hammered much more as well. So there are bi-directional, so compounding events, some of them, and if there is unidirectional compounding or domino effect, and there can be contagion effects on multiple risks when you have multiple arrows going from one. Food yield and quality loss is going to affect food price increases as well as reduced food security, and food price increases also then feeding into food security here. Okay, seems very obvious, and yet all these links have to be looked at. Looking at equity and inclusion in climate change actions that prioritize equity, climate justice, social justice, and inclusion lead to more sustainable outcomes, co-benefits, reduce trade-offs, support transformative change, and advance climate resilient development. These are of course arising out of analysis, but how to bring them about, how to actually make sure that equity, climate justice, and social justice and inclusion are prioritized in adaptation mitigation is not always very obvious, either through policies or other incentives. Adaptation responses are immediately needed to reduce rising climate risks, especially for the most vulnerable, women and children included in those, as well as poor people. Equity, inclusion, and just transitions are key to progress on adaptation and deeper societal ambitions for accelerated mitigation, which is said with high confidence. Another point to be made: near-term mitigation and adaptation actions, rapid and far-reaching transitions across all sectors and systems are necessary to achieve deep and sustained emissions reductions and secure a livable and sustainable future for all. These system transitions involve a significant upscaling of a wide portfolio of mitigation and adaptation options. Feasible, effective, and low-cost options for mitigation and adaptation are already available, with differences across systems and regions, which is again known with high confidence. There are multiple opportunities and for scaling up climate action. Maybe I should leave this for the next podcast because it's a fairly long one, which brings us actually pretty close to the end. So let me read a few more points and then go back to that. Co-benefits of adaptation and mitigation for sustainable development goals. Mitigation and adaptation actions have more synergies than trade-offs with sustainable development goals, which should be good news if we pay attention. Synergies and trade-offs depend on context and scale of implementation. Okay, so that's always important within the country and across borders, how mitigation and adaptation actions are adopted. For example, India sitting in the middle with vulnerable countries, more vulnerable countries around it like Nepal, Bangladesh, Bhutan, Burma, Pakistan, Sri Lanka, and so on. Can it think of the scale of implementation that will make the entire region more resilient and more equitable, just, inclusive, and so on. Potential trade-offs can be compensated or avoided with additional policies, investments, and financial partnerships, which is known with high confidence. So incentives that are offered from the Green Fund, Climate Action Fund, or the UNFCCC frameworks, international agencies, etc., World Bank, development banks, they can assure that the scale of implementation can be worked at a regional scale rather than at a scale that is bounded by geographical political boundary lines and so on. So this is the near-term adaptation and mitigation action which have more synergies and trade-offs with sustainable development goals. I won't read all of these, so you have the Sustainable Development Goals 1 through 17 here, which cover everything from poverty to education, food security, energy, and protection of biodiversity, etc. And you have energy systems, urban and infrastructure here, land systems, ocean ecosystems, society, livelihoods, and economies and industry. So you have here the keys provided by synergies, trade-offs, and both synergies and trade-offs, and here the blank regions are united evidence or limited evidence or evidence, no evidence or no assessment. Limited evidence, no evidence, or no assessment. Okay, so each of the sustainable development goals has synergies with each of the systems, ecosystems, energy systems, urban and infrastructure, land systems, and so on. So it is good to have here, and some of them are not assessed for various reasons and so on. So let me leave this here and then come back to multiple opportunities for scaling up climate action and make a few other points before we wrap up the synthesis report of AR6 released in 2023, which is adopted after all the parties have voted on it. Okay, so let's come back to that in the next